This is the Angry Birds Bird Minute, sponsored by Angry Birds for their 15th anniversary, where we tell you all about a cool bird that may or may not be angry. Today's bird is the red-tailed hawk. The red-tailed hawk is a medium-sized, drably colored raptor. They are extremely adaptable and common throughout their range, which stretches from tropical Central America and the Caribbean all the way to Canada's boreal forests and tundra. They're also the most successful bird voice actors. The fearsome cries most commonly heard in TV depictions of bald eagles, "Caw!" is actually that of the red-tailed hawk. Bald eagles, though large and impressive in their own right, have smaller chirps, closer to what you would expect from a dog's squeaky toy. Congratulations, now there is something that you will think of every time you see a bald eagle on TV or film in the future. But are they angry? On a scale of 1 to angry, the red-tailed hawk is screaming mad. Caw! This is Wild Green Streams. I'm Rhett.
I'm Io.
And with us today is Dr. Anthony Waddle, who has done some really, really interesting research into the means of protecting frogs against a deadly pandemic that has been going on for a couple decades now.
Welcome to the podcast, Anthony. How did you start to get into this work? And also for people who don't know, because people in the field, chytrid has been sort of a household name for a couple years, but people who aren't familiar, what is it and why is it important?
Yeah, okay, so chytrid is an aquatic fungus. It affects amphibians. Chytrid is like kind of this general term for a giant group of fungus. It's like calling everything that has like, a mushroom, whereas like there's many different types of mushrooms. But we use the word chytrid because the name of the actual pathogen is impossible to pronounce. So we just call it chytrid. There's actually two species, one that affects primarily salamanders in Europe. Mm-hmm. We call that the salamander chytrid fungus. And then there's just the amphibian chytrid fungus, and it seems to infect kind of indiscriminately any amphibian it encounters. It's spread from Asia, we think through the pet trade primarily, and then also bullfrogs are traded all around the world because they were a food source. And then xenopus, which is like this aquatic frog, was an early pregnancy test.
Oh, the clawed frogs.
Yeah, the clawed frogs. And both of these species don't die from chytrid, but they can carry it. These were like kind of the presumed mechanisms for their spread. And the genetics does say that the source, like the genetic like bounty, I guess, is in Southeast Asia. After it's spread, it goes into new environments with new frogs that have never experienced it. They have no natural defenses, and it's really caused a lot of devastation. So here in Australia, we've lost 6 species, and there's numerous more that we can only keep in captivity, and it's much, much worse in the Latin tropics. So it's a big issue. I hate to start off on a negative note, but no other invasive species or pathogen has ever caused this much harm. So you think about cats and rats and cane toads, all these really notorious, terrible invaders, and they are trumped by chytrid because, for example, cane toads, they're this reviled sort of pest species in Australia, but they've never caused an extinction, whereas chytrid has caused 6 already. And there would be more if there weren't really dedicated people working to stop it.
So I want to actually go back to something you referenced. It's a strange middle. It's another strange middle but for the story of this fungus is, so you're saying that it probably originated in Southeast Asia based on the genetics and what we can tell. And then, but the way it's spread around the world is really kind of a bizarre story. It was used as it got spread on frogs that were used as a pregnancy test. Is that right?
Yeah. So how it works, these frogs were just given to hospitals all over the world. And we're very similar to animal. This is why evolution is nothing makes sense except in the light of evolution is the famous quote, biology, because the hormones that we produce and frogs produce are so similar that you can trigger ovulation by taking hormones from a potentially or a pregnant woman, giving them to the frog, and if the frog ovulates, then that the woman's pregnant. And how that works is you would take urine from a woman that wanted to know if she was pregnant. You would inject a bunch of female frogs with the urine, and if the frog laid eggs the next day, you'd be like, congratulations.
Instead of 2 lines, it was 10,000 eggs.
Yeah.
Not only are you a parent, but you are now step parents to all of these frogs.
You take them home with you with the results of your pregnancy test.
Yeah, that's what they put in the take home bag when you leave the hospital.
Yeah, that's always a really funny story. But obviously, we have better means for pregnancy tests now. But it was a really interesting, I think, a really ingenious way to get after, those early tests. But also, we didn't know what we were doing. Globalization is this like thing that we just did, and we didn't really think about like the repercussions of it.
Yeah.
So spreading pathogens all around the world, spreading pest species all around the world, spreading humans all around the world, carrying pathogens and pests. Yeah, it ended up causing a lot of harm to biodiversity, not just for amphibians. You think about last time I went to Florida, I struggled to find any native species. It was a real struggle. So, you could look at these like ecosystems that have been like fundamentally altered by.
Where'd you go in Florida, by the way?
I was in Miami.
That's where I'm from. Yeah, Miami is a lot of ornamentals and introduced species, at least like as far as plants, but pretty much everything is involved.
I talk a lot about, I had a similar experience on a work trip to Hawaii where I was on Oahu and I took a hike just kind of on a cross section of the island that I just took off and went on. And it took me like all day to find one native plant. It was bizarre. I was like, this is really interesting. I'm seeing stuff from every continent, but it's like being in a zoo or something.
Yeah. That's like a more philosophical question in like conservation is like, what are we conserving now? Like, are we trying to get back to what it was, or are we trying to conserve what we can in the ecosystems that have emerged now? And when I look at Florida, I'm just like, wow, I'm so glad I don't work here. This would be a nightmare.
I do. It is. Yeah.
Or arguably, if you're an invasive species ecologist, job security forever if you work in Florida. So, pros and cons.
True.
So as far as chytrid goes, it spread around the world because there was this frog that was both a carrier of chytrid and it was immune, and it was great for pregnancy testing, which is the weirdest mashup of traits ever. So that's how it got everywhere. What happened next?
So it's then pet frogs and also frogs for food, probably. But what happened next is there was nerds like me studying frogs in the forest in Central America. And they just watched real time as their species were just disappearing. And frogs have really like dynamic populations. You might have one season where you see a couple, the next you might see millions. So it's normal to have like a low season. But they were going year after year not finding the frogs anymore. And this was actually as early as the 70s and 80s. And there was a World Congress for Herpetology where they finally kind of everyone was like, I'm seeing the same thing here, and I'm seeing the same thing here, and it was all around the world. And this really, like, one of the most interesting people I've ever heard of, his name was Rick Spears, an Australian, like a medical doctor, public health professional, did all like just hobbyist herpetologist, was like watching the pathogens spread through Queensland. And there was like, people didn't know why the frogs were dying. They were like, maybe the UV, maybe there's like pollution, but it was happening worldwide. It just didn't really make sense. And there was a lot of people, it was like a really aggressive, nasty debate between people who were like, it's UV radiation versus pathogens or whatever. But this guy, having his background in like being in medicine and public health, was pretty sure it was a pathogen. And got some money together to get a graduate student named Lee Berger. That was one of my PhD advisors. And she worked with the Australian government and people all over the world to look at the tissues of the frogs that were turning up sick, and found this fungus. And she called the disease they caught chytridiomycosis. And that was the first like real evidence that there was a pathogen causing this worldwide decline of amphibians. And you'd think that she would go and present that research and everyone would be like, yep, that makes sense. But it took almost 20 years before chytrid was like accepted as the cause for the global collapse of amphibians. And there's always going to be holdouts, but there's just so much evidence now, just an unreal amount of evidence for when you go into museum specimens. There's tons of frogs. You test them, chytrid arrives, the frogs disappear. And that's been done to death in systems all around the world. Also, bringing frogs into the lab, and just expose, like, are they susceptible? Those susceptibility trials have been done in numerous species. And then also just like field monitoring. I just got done setting up an experiment here in Sydney, and we had some administrative delays, and we got in too late, and the frogs are already sick and dying. It happens
Wow.
every year. So it's not like it's something that's happened and then it's done and now we're dealing with the aftermath. It continues to happen, and it's just as bad now as it's ever been. So the urgency like that you hear in my voice is real because academics want to move on to the next shiny thing. And I was like, no, this thing is still here. It's still a challenge. We still need to deal with it. And we have exasperated, overworked, under-resourced people that are holding on to these species. And it may be one or two really dedicated people keeping them on the planet.
There was an Onion article that said U.S. Fish and Wildlife biologists ask citizens to grab any animal they can find and just hang on tight.
Yeah.
It kind of reminds me of that a little bit.
And it's not far from it. The way conservation has been done and why some species still exist often is just a few people taking, the last bucket of minnows from a pond. I went to the University of Nevada, Las Vegas for a bachelor's and master's, and there's the guy who started the department there, Deacon, carried out these fish from this like desert spring because a rancher was like, I'm draining this. I don't care. I don't want these fish here. So he just took them out in buckets. And now they're still alive. That species still exists because that one person made the right decision.
That's amazing.
We have the same cases here with frogs. So the frogs are blinking out. The zoo personnel and government officials came in and took the last ones, brought them into captivity. And that's why we still have southern corroboree frogs. This really iconic frog here in Australia is because they did the right thing.
And chytrid so far has taken out at least 90 species of frogs. Is that right?
Yeah, that's a conservative estimate because we're describing frog species like all the time. Those 90 species are just the species we knew of that then went extinct. And in the areas where there's large scale extinctions, like in Central America, that's a hot spot for description. So we've likely lost countless more than that.
Right, and plenty more that we knew about, which are just missing in action, and we're not sure if maybe there's a holdout population out there still as well.
Yeah, sure.
We've gotten through the problem, the setup, and the darkest part of the story. So what kind of solutions are there? And there's one in particular that we brought you on for because it came out recently in your research, and it's kind of a funny solution because it involved a brick. But we're interested in just like, what are people doing? What can be done in general to help with this?
I also just want to interject that I have a stuffed animal, southern corroboree frog, from when I was in Australia last. And I was like, this is his moment. He's being talked about right now.
That's amazing. Yeah, that's so cool. The brick story is I had been working on immunizations against chytrid, and I'd presented at a conference. This very well-known herpetologist here in Australia named McShine saw that, and he was like, oh, that's really cool. Come work with me in Sydney. And me and him had talked about this kind of idea about habitat. Because we know that there are natural habitats that are refuge from chytrid. So it's like something that's already known. It's been well known for a long time. And then people have been like suggesting maybe an artificial habitat. But academics love to talk about doing things and write papers about maybe doing things and talk about how we should maybe be doing things, but no one actually does the experiment. So I've been like kind of lingering on this idea that we could be doing like some habitat stuff. But also there wasn't really the infrastructure. But when I came to Sydney from Melbourne, there was this amazing infrastructure here, and we could actually scale this and test it in like a real world situation. We were working on the species called the green and golden bell frog. They're known to bask in the sun. They like to heat up. And in winter, they have epidemics of chytrid. So they have these very discrete, like in the summer, chytrid goes away. They do great. They breed. There's tons of frogs. And then in winter, lots of them die. And you would see very few getting through winter. But we did this experiment where we like kind of acclimated them to winter conditions, and then we stuck them in a thermal gradient. So one side is hot, one side is cold. And we said, choose where you want to be. And the temperatures they chose were screaming hot. And chytrid likes to be cold. So it's a cold killer. That's why in winter it's so devastating. And we're like, well, if we give the frogs the opportunity to thermoregulate in winter, they should be able to get rid of their infections. So we did another experiment. We infected them. We put them in a thermal gradient, and like almost instantly they lose their infections. I'm like, all right, this is going to work. So we just need to find a structure that attracts them, allows them to heat up. And yeah, that could be something that we could use in the wild. And I would love to say a pile of bricks was my idea, but there's Dr. Harmer designed an experiment in 2003. So this is 20 years ago.
Wow.
where he was just like, let me just see like kind of what kind of habitat, urban habitat they might use, and had this big pile of bricks and some other like plants and water and stuff, and just found the frogs love to sit in bricks. And actually, when this paper was published, he sent it to me. He's like, "Oh, maybe this will give you some insight." I'm like, "Dude, this is what inspired our work." And it's just these frogs are really well adapted to urban and suburban environments. So this kind of they like to live on rubbish, fortunately for us. And we kind of fiddled around with certain designs, and we just kind of ended up stacking up bricks. And right before the experiment started, Rick was like, no, let's do it like this. And then so we were like making these decisions in real time, and we built this structure, and I put them out there. I had all these frogs I had to like expose to chytrid and clear and expose, and there was just like so much work. And then we just did it, and we just crossed our fingers it would work because, I was a PhD student. We only have so much time to do our work, and this was one chance. We had one chance to do it. That said, COVID was happening. We had a 100-day lockdown at the same time. Every week we had to like beg to be able to work on this project. And luckily at this point had been moved outside. And over time, like the first couple of weeks, there was no difference. So we're just dejected. I had to catch like 240 frogs every week and test them. And but then like as the weeks went on, it was clear that they were like the frogs that had access to these hot shelters were just doing tremendously better. And we're like, finally, like we have a data set that shows that we can create some habitat for the frogs that can prevent this epidemic of chytrid.
These are just, they're painted black bricks with holes in them, right? Like that's kind of what they are. And the holes are just where the frogs naturally go.
Yeah, I should have like started with that. They're just 10 black painted masonry bricks. They're made of clay. We stack them up in like a hotel style. So there's like 3 of them on each level, and they're perpendicular to each other. So they have like little gaps in between that bigger frogs can wedge themselves into. And then the holes, like a medium-ish or male frog could go into. The female frogs are much too big to be wedging in the holes. And we put a greenhouse over the top. And what the greenhouse does is it allows the shelters to get much hotter, and it holds in heat, also holds in humidity, because frogs obviously can't just heat themselves up. They also have to worry about losing water because their skin is very permeable to water. So having this like hot, humid environment allows them to get hot enough to get rid of chytrid, not lose a ton of water. And also having high humidity allows their body temperature to rise to the level of the ambient temperature inside. Whereas like if it was dry, they'd be losing heat through evaporation. So it's like this double whammy. Like their body temperatures are going to be higher. Also, they're like it's meeting their like biological needs inside. They love sitting in them. So every time we would go out and sample the frogs, you would find we had these like mesocosms or like miniature habitats set up, and we had 12 of them. Among those, we would see them 75% of the time inside these shelters. And I reckon the rest of the time were just frogs that jumped out of the shelters when they saw a giant human coming in.
I didn't think of it until now, but it's sort of like when like your body as a human has an infection and your body runs a fever to try to like cook it out of you, essentially. Is that what you think is happening? Do you know the exact mechanism for why it works, or is it at the moment just like we have a kind of an idea, but we don't know the like nuts and bolts of it yet?
So the mechanisms are so fascinating because studying wild animals and immunology is just, it's like a new kind of frontier. And I think the Tasmanian devil facial tumor people are like setting the bar. Like they like have really shown me, like I work with Andy Flees at University of Tasmania, and he's just like, every time I talk to him, I'm just like a tiny bit more inspired to like try new things and be bold. And they've developed like cancer immunotherapy in a wild animal. It's just crazy what he's doing. Anyway, that's an aside. Study the actual mechanism. The technology is caught up. So we don't need to have like, you don't need to spend years and millions of dollars to develop like special reagents. The sequencing technologies are good enough for us to know what's going on in their immune system to some degree, and we can make predictions on what the mechanism is. That said, like I'm a conservation biologist, we know it works. So I'm like, okay, done. Let's move on. So we don't know what the mechanism is. It's likely their immune system is just more active. And another like kind of nuance of this work is we know that these frogs, once they use these shelters and clear their infections, like a frog that has a cleared infection from heat is 23 times more likely to survive a subsequent infection. We can vaccinate them.
I literally highlighted this in your paper and sent it to Io. I was like, this is the craziest thing when I read it.
And I was like, I already read it and I'm already excited to talk about it.
This is the synthesis of like my past work and this like newer thermobiology stuff is I knew we could vaccinate some frogs. Some frogs don't respond to vaccination at all. They actually become more susceptible. And we think it's their immune system is just completely dysregulated by chytrid. But for some species like this one, it seems like you can. And vaccinating wild animals might have some utility if you're like releasing individuals into a population and you want to keep some amount of adults on the landscape. But long term, it's not really a solution because you have to continue to do it because the offspring aren't going to be resistant. But having these structures, it's kind of like the frogs can just do it themselves. So they propagate resistance into the population. Their babies are born, they do get infected, but then they can use these structures. To me, like it's not a perfect solution, but it's something it's better than like what we have, which is nothing. So
Yeah.
and I think it's made a big step towards something that could benefit an endangered species. There's a lot of like this is one thing that is like a sore point for me in my field is the criticisms I get is everyone's like, well, this won't work in a glacier lake in the Andes. And I'll be like, and like this is me being very candid. When I do these studies, I'm studying the species we want to protect in the study. I'm not using some tangential model species. There's no reason to do that. We have access to these animals because of really good partnerships with the zoos and stuff. So build those relationships first. Do the experiments in the species that will benefit from it, and then you're not wasting time and money. Also, if it won't work in your system, it's not about you. It's about okay. I don't care if it doesn't work in your species. It works in this endangered species, and why is this not good enough to celebrate? And this is something I will be on a soapbox for the rest of my life about. If you say, well, it won't work in this case, I'm like, okay, but what do you have that's an alternative for your case? Like if you're so confident this isn't going to work, what is an alternative? What is going to solve it for every species on the planet? And like the one, this is like my last bit on this, and I'll get off my soapbox. This is the like kind of metaphor or like the comparison I like to say. So say every mammal on the planet was impacted by poaching, and you came up with something that could help, say, giraffes.
Right.
And then everyone that studies mammals is like, no, bullshit. It won't help cheetahs. It doesn't make any sense.
Well, I study pocket gophers. Yeah, right.
Yeah.
Yeah. So like, give me a fucking break.
Yeah, totally.
And just acknowledge that it's not going to work. It's not going to work for every situation, but that's not a reason why we should give up on it.
It's so like makes me laugh almost at the absurdity of like there are so many instances where it's like, oh, I have, someone's like, oh, I found this like really cool recipe. I saw this. Oh, this was like a tweet from a while ago where it was like twitter.com is the only place where you could say, I love pancakes. And someone will say, oh, so you hate waffles? That's not what I was saying.
Twitter and academia. Yeah.
Yeah. Or I saw someone, it was in like TikTok comments where it was like a person was making an eggnog recipe and someone commented was like, do you have any alternatives for people who can't have eggs or dairy? And the original person was like, you're just going to have to sit this one out. Like, there are other things for you, but like, this is for one subset of the population. If this would, we can work on your problem later, but we're talking about this right now.
You know what it's like? This kind of defeatism pattern, I've noticed it as well, and we run into it a lot in our work in one way or another. It's as though someone figured out the perfect training regime to be a gold medal swimmer. And then someone came and looked at that and said, this is useless because I do shot put. Like, it's like, well, we should also learn how to do that, but that's a totally different problem. Like, it doesn't have to solve every single problem to be worth it.
Exactly. I think the either or mindset is, it's just like this really toxic way of thinking. And it keeps you in this cycle of negativity. Like there is no hope, there is no hope, there is no hope. Oh, okay, well that will work there, but there's not hope for this thing, so we shouldn't care about it. And to be fair, there's a lot of people that have really been excited about this type of work too. So
Right.
I'm just talking about grant reviewers because, I had,
Yeah.
before this paper came out, I had grant reviewers say, this isn't interesting. This is
Yeah,
a dumb idea. And it's just really, it's disheartening to hear people from my own field, of course they're anonymous, but like
right,
to say that like, we have really, really strong epic data that says it works.
right.
We've done our due diligence to make sure we've done good experiments. And then someone just to be like, Matt.
Reviewer number 2, turn your location on. I just want to talk.
We should get a psychologist or a sociologist on the show sometime to talk about this, because I see this all over the place in conservation. Also, kind of in a weird way, a similar problem of like how big and global and complicated it is like climate change. And
Yeah.
I see anytime there's anything that can solve part of climate change, most of the articles I see about it, like public articles, not necessarily scientific ones, are saying that that thing is useless because it won't solve climate change. And it's like, well, planting trees is really great for climate change. It won't solve all of climate change, but that doesn't mean like it's totally useless and we should scrap it and do something else. I see versions of that for not just trees, but like for every solution to climate change. I see that same kind of fallacy coming up again and again. And it's like, it's just not helpful. Like, it's so much better to be like, this solved a part of the problem and that's great, and we can keep building onto it.
Imagine if we actually propped up our leaders that were successful and had good ideas instead of just saying, oh, it's not my idea, so I don't care about it.
Yeah.
Yeah,
Anytime someone comes up with like I worked with this I have a fellowship in called the Schmidt Science Fellows, and I meet with these really smart people, and a lot of them are climate change scientists, but some of them are just engineers. So there's engineering solutions. And when we initially met, they're like, engineer, it's so sad we have to engineer our way out of this problem. And then they're like, well, your solution is this biological based solution. It won't solve all the problems. I'm like, don't you guys see that you could be working together? It's like so obvious. And not that like I'm the like the most righteous one that could see
oh,
everything that's
sure.
clear,
Yeah,
but
yeah.
it took me like almost 3 years to be like, hey, we're like having these same conversations over and over. Why can't we just like say, good job, dude? Like that's awesome that you've like
Right.
come up with this great thing. I'm doing this other stuff. Maybe together we can like make an impact, make a dent.
Yeah.
So
Right.
And especially like for me growing up and like learning about wildlife and science, chytrid has always been sort of like the boogeyman of, it's this terrible disease that has like ripped its way through our amphibian populations, and people for so long didn't know what it was, and then even when they figured it out, they didn't know how to stop it, and like only recently have there been some progress being made. So like when I came across these papers, I was like, do people know about this? Like, are people talking about, like, this is really exciting news that this like ubiquitous like dark looming specter in the corner is, you're like realizing, oh, he's not all powerful. Like there's things that we can do to at least stem the flow. And like, is it going to be perfect the first time and get it hit a hole in one? No, nothing ever is. But you need to like start taking those baby steps. And the fact that there's baby steps at all, I was like, this is like crazy. It's like a little glimmer of hope that like the evil could one day be defeated. It's not just like throw in the towel. I was like, this is so exciting. We need more hope. Let's bring back some like hope core inspiration. Like we need more of it.
yeah, I rate that high. Yeah. If you're not creative and you don't have any ideas left, maybe you have more to learn. So like,
Yeah.
I think that's the case. If I like lose inspiration, I don't feel like I'm like coming up with any good ideas that have any kind of promise, which does happen all the time. Like I
Uh-huh.
just go talk to other people. So you have to be surrounded by people. So like I will say like this project was done with a lot of help.
Sure.
And Erin Sowers, one of the authors on it, she's actually based in the States. I met her at a conference. I'd been reading her papers, and I was just like, this person's a genius. I just need to talk to them and just like suss out like if this is something we should do. And all of our laboratory like thermal experiments were based off of stuff she had done in the past. So, and she just got on the phone, was super happy to help, and just like really lovely. And I was like, this is such a breath of fresh air, and I'm just so excited to be working with this person. And then the result was amazing. We like found all the things that we thought we would see, and this is someone who inspired me and kept me hopeful. So it's not that just I'm like this like one little ball of
Right.
positive energy. I obviously have to think that's quite negative, but
Yeah.
I think it's finding those individuals and working with those individuals that keeps me going.
That is a great saying. Like, I'm going to think about that probably forever. Of like, if you're feeling like you're creative and you're kind of at a stop point, just talk to other people. Because so often it's like you hit a wall, but then you talk to someone else and they're like, oh yeah, yeah, you could do it this way. That's like so great. And do you think because separately you have worked on like sort of vaccinating these frogs and also the saunas, could those two things work in concert and be like mega effective, or is it sort of like you either do one or the other, but they don't amplify when they're added?
Yeah, so I've just talked to a contractor yesterday about getting frogs at one of their sites, and this is the vision is if you don't have a lot of frogs, the saunas aren't going to work. So like if you have,
Mm.
as some proportion of them will use them in the wild, we have them set up in the wild, and when there's tons of different types of habitats, you're going to get a little bit less occupancy. So like not every single frog in the population is going to come across and use one right away. They might be neophobic, so like the new things are scary.
Mhm.
But if you release frogs to a new site that has very few individuals that are vaccinated, you have adult individuals in the population that can reproduce. And these frogs produce like up to 10,000 eggs at once. They're incredible, like incredible fecundity. And after that, even if, if you have 10% of 10,000 frogs using these structures, you're going to have incredible survivorship over the winter. And that leads to a much like stronger population over time. And so like initially you want to release individuals that are resistant. You don't want to establish a population or augment, like put more individuals into a population that are susceptible because you're just feeding chytrid frogs.
Hmm.
It's pretty useless. And making sure that every individual, those precious individuals you spend a lot of time working with are resistant, I think is key. So initially the vaccines are important, and then subsequently you probably won't need them because the shelters will do the job for you. But with really small populations, the shelters by themselves probably aren't going to make that much of a difference. And I'm talking about I work in a population now where there's 50 frogs. So that's it. So you have 50
Hmm.
individuals. If you put them in that, and it's a huge area. So we have to put out tons of these shelters. And if 10% use them, that's not that many frogs, not enough to reproduce. So
Hmm.
yeah, the idea this year is we ended up vaccinating half the population. And then we put the shelters out and they'll be like more useful next year.
Mhm.
But we do find frogs in them with screaming hot body temperatures. So some proportion of the frogs are already using them.
So, do you think that there are solutions like this either developed now or like in development that are, I hate to ask this question after we've talked about it the other way, but that are more broadly applicable? Like, either lots and lots of little solutions or like a few big ones that you know of that are coming along that seem promising?
I am going to toot the horn of Australia. The best conservation research in the world is done here. Without hesitation, I can say it, especially for frogs. Oh, actually, I'll say for frogs, not for,
Sure,
like
sure.
big mammals and stuff. We have terrible reputation for that. Uh, but so a one size fits all solution for me is genetic engineering. So I also work on that now. So this is like a very controversial thing for me even. But like what we're looking at is an extinction of an entire branch of the tree of life.
Mhm.
And we're losing species now as a whole in terms of biodiversity faster than we've ever lost them. Nothing we're doing is even making a dent in slowing that rate of biodiversity decline. So I think something like if we want to keep species on the landscape for things like chytrid, I think using synthetic biology, using genetic engineering is probably going to be the kind of the silver bullet.
Mhm.
And I say that because it's not like in the future the habitat of these frogs is going to be gone. So we're conserving for now and for the future. So we have to think about future proofing populations. And for things like climate change, if there's no water, we can't have frogs.
Mhm.
So it's kind of pointless to be, trying to address an issue if there isn't going to be habitat for them.
Well, you can address a piece of it so you'll be ready when the rest of it gets solved.
Yeah, true. For chytrid, it's like we have pristine protected areas where these frogs could live,
Mhm.
and otherwise it's perfectly suitable for them. But chytrid is theirs; they can't. So it's this kind of unique scenario where we can pinpoint this one problem. This is the overhanging, like looming problem for the persistence of populations. And there are frogs that can tolerate or resist infection. And that's in Australia, that's in Southeast Asia, that's all over the world. So in a community, some proportion of frogs will go extinct, some will be tolerant, some will be resistant. And I think finding out the genetic underpinnings of that, or even just finding a product or something that they could produce in their skin that kills the fungus could be a way forward. And yeah, that's like so I have like kind of this like tiered approach to conservation. There's ecology. If we can find places where they're naturally going to persist, fine. Vaccines, if we're trying to establish new populations where we think that would be like a good jumping off point, vaccines. Artificial structures for species that can and do use high temperatures and can prevent themselves from dying in the winter, we can use those shelters. For species that don't respond to vaccine, cannot heat themselves up because it's not a temperature they can survive, and that are extinct in the wild, that's a candidate for using something like synthetic biology. So it's not like I'm just going to start CRISPRing every frog on the planet.
That sounds fun though.
But we're starting to do really preliminary research and very carefully assessing kind of the vibe with the IUCN, because the IUCN currently, their current recommendation is we should be looking at this because they acknowledge that the threat to biodiversity is so extreme that we need to have some novel solutions, but also we need to be very careful. But there are like some caveats. Like I've been injected with a transgenic virus. One of the AstraZeneca vaccine for COVID is transgenic.
Sure.
I eat GMO food all the time. Insulin that people use is from a transgenic organism. I think and then Australia, like our stakeholders, the people that are like really panicking about keeping these frogs alive are like open to it. They're actually pushing for it. So I think that's the future of conservation for these really hard going species.
I think that is really exciting because, like, over the conversation, thinking of like the vaccines and stuff, and like when for the frogs that work, it's great, but I imagine you have to have the frogs in hand to be able to give them the vaccine. So I'm like, what if there is a way that we could make the vaccine contagious? So we could just release the frogs and they could spread it, which,
yeah. So let me just draw you to my 2021 paper about transmissible vaccines against chytrid.
Yes.
We did that experiment in 2021. So that was awesome. So I was an undergraduate and we were like doing these challenge studies, seeing if this species it's called the Relict leopard frog. It's native to the Mojave deserts. It used to be in Utah and through all those deserts, but it's only like in a couple places now. We didn't know if chytrid was actually the cause of decline. Like many North American species have been impacted, but they haven't been like so impacted like other areas. So we were just doing this like challenge study to see, are they susceptible? And we're using these strains of chytrid we got from people in California. And they were a bit old, but we used them. The frogs didn't die. And we were just like, wow, cool. Maybe chytrid's not such a big deal for this frog. And then when I started my master's at UNLV, I just got chytrid from the local populations, and then it was really deadly towards them.
Oh.
So I was, oh shit. But then I was like, well, we have these like weakened versions of chytrid. And the first polio vaccine was like a low virulence polio, and it works really well. So we just did this study where I wanted to see, can low virulent strains of chytrid be used as a vaccine, and can they be used as a transmissible vaccine? So like you infect like a few individuals and then it spreads to the population and protects them against really nasty ones. I mean, there's lots and lots of caveats to that. We did this like proof of concept, just like infecting a frog, housing him with other frogs, and it spreads. It doesn't get more virulent as it spreads. Cool. And when we gave them something really nasty, they were like well more protected than frogs that had no prior exposure to anything. Mm-hmm. So we have done that. And I think the future, kind of like how that could be expanded in the future, is finding like an inert virus that's really infectious. And you give it it's called an epitope. It's like the chunk of the pathogen the immune system responds to. We don't know what that is, so you'd have to figure out what that is. But that could be the way to do it without having like infectious chytrid. So, and the Ebola vaccine people that work in great apes they were the inspiration for that as well, because they were thinking like, if we can spread a vaccine for Ebola through the great apes, it protects them because they do die from Ebola, but also spill over into humans. So it's like this wildlife and public health kind of approach. So yeah, we have done that experiment. I would love to follow that. Right now, I'm only one person, so I'm trying to like get some students, get some funding, and like actually scale these projects up to a place where we can test them and get them working in the wild. But yeah, for now, I the hotspot stuff is cheap, so I'm like, let's just go with the cheap one that seems to be working, and I have these other in the kind of in the wake, waiting to be done.
And the hotspot thing reminds me, I saw this thing talking the other day about simple like ideas where the product itself didn't change, but just the marketing did, where it was about like hydration packets, which, salt packets for like consuming stuff, where these like, salts have been, magnesium salts, whatever, have been around for ages. And we're, whatever. But then this one guy came along and was like, there's a potential here. So he rebranded them as like hydration packets and sold them as like individual sachets. And it's now like $1 billion industry, and the content hasn't changed. And you can still buy the like, just like bulk salts and like mix it into your thing. And so that's sort of like there's a simple solution, like a bunch of bricks in a greenhouse, which is, it's pretty cost effective. And it's like, oh, that's actually like super, super helpful. I think that's great for just, that it's working, and also just like inspiring in general to think like their solutions are out there. We just have to discover what they are. And they're sometimes right under our noses. And, it does, you don't have to, have access to like, millions and millions of dollars in grant funding. Although if grant writers and funders are listening to this, you should fund Anthony's work. There's still feasible solutions out there that are not going to like financially break the bank. We just have to like figure out what they are.
Yeah, I'm thinking even with this particular study, so there's like 7 of these priority populations of bell frogs. And if I could get in the room with like a venture capitalist, I think we could build, what I would love to build is like a mobile frog vaccine clinic where we go along the east coast of Australia. We take the remaining individuals in the population, we vaccinate them, and we set up hot shelters at the same time. And I do that every year for like 5 years and see if we get an increase in the population. We will. We know the vaccine works. It's really highly effective. So we'll definitely get more individuals in the population. Yeah, and that's like my like pipe dream, is have like a frog on the side, a QR code so people can see what I'm doing. It would be great public like awareness. We could plug Frog ID, which is a citizen science app where people can record frog calls, and we can like get the community really excited just by having a car that goes down the road, like what was the hot dog mobile?
The Oscar Mayer Wiener mobile.
Yeah, exactly. This is the frog mobile. I was just like thinking about that the other day. I'm like, oh, I wish there was just like, yeah, it wouldn't even be that much. It would be cheap because it would just be paying for my time and then me to like retrofit this like RV or whatever to be able to do the research. It's not very academic of me, but I think that's like how I get my research out, because right now the way we get our research done and like translated is we have to do it ourselves. It's the same with startups. Like you develop a product is going to make a lot of money, but who's going to actually pick it up? You're the one that knows it best. Why aren't you the one taking it in? And universities realize that. They have incubators, they bring in venture capitalists. So I just need to find this network of philanthropists, which I'm starting to do now. So like for funding and stuff, I think I'm early in my career, but like I think there are people out there that care about this type of work, and we can get support for it. So I'm not super pessimistic about all that. But yeah, getting some funding would be good, but also realizing like it won't take that much. We're not going to make money. Conservation spends money, but we might be a way for, an organization to offset some of their tax burden or whatever. And we can help corporations meet their UN sustainability goals. We can help them tick boxes to raise their share price. So there is value in like working with us. It's not like we're just a money sink. So if money is the bottom line, I can also make an argument to those people that we can help them with that too.
And to have a frogmobile, like what better marketing could you have than that? Like that's amazing.
Yeah, it could be the Coca-Cola Frogmobile.
Yeah. Sponsored by Home Depot.
The Microsoft Frogmobile. Come on, guys.
Well, if you know about Australia, you might know about Bunnings Warehouse.
A little bit, I think.
It's like the Home Depot or Lowe's of Australia, and it is a staple in Australian culture. So you go there on the weekends, you spend a ton of money on like nonsense you don't need. It's like home improvement stuff. And then they have a sausage sizzle, so it's usually like the Scouts or like the Lions Club or some community group, and they sell sausages. And in Australia, they don't use hot dog buns; they just use a piece of bread.
I think
And
I have a brilliant business idea that we can use to fund your research.
yeah, I think a sausage sizzle will do it. But that I think Bunnings Warehouse, it would just be full circle because I'm trying to become Australian is like if I got Bunnings Warehouse to sponsor the research, it was just
They could sponsor your citizenship. It would be perfect. And presumably they sell masonry bricks if they're like home improvement. So then they're funding it because they're using their product. And then it's like the Bunnings masonry bricks are saving the frogs. Like, I think the grant writes itself.
It's a natural fit.
Yeah.
And so far I've been given the phone number of someone who is a retail worker. I was like, come on. The university could do better than that.
True. Well, normally at this point in the show, I ask if you have any plugs you want to do, but I think we just went through that stage. Do you have anything else you want to promote or talk about?
A natural podcast guest seamlessly flowing into the plug section of the show.
Basically a pro.
Yeah, I mean, for this work, like it's my responsibility to get it up, right? So I'm not asking for like the general public to like come in. And I think I love the purity of it. Like I've developed this thing. I hope that people that live on the east coast of Australia might hear this because they can also help by building these. Like bell frogs live in people's backyards along the Central Coast. So the Central Coast is just north of Sydney. So the coastal region north of Sydney up to a city called Newcastle. The frogs live throughout there. There are some populations, and building these structures in your backyard, like one or a few of them could provide these little refugia for the frogs in winter. And if they want to do that, I have a guide on how to do it. It's a very simple approach. All the stuff that you need, you can buy at a hardware store. It's cheap. This type of work I really love. So if like the general public just wants to email me personally for advice, I respond to every email I get from people. And I love talking with people about frogs. Like even if they just want to be like, oh, there's this frog in my yard and it sits in this pipe. That to me like is an anecdote like I'll take and think about. I have this pottery club down south that wants to build them, and they have sent me all these pictures of where they're finding frogs on their property.
Oh.
Thinking about urban ecology is a way that we can buffer these populations, these larger populations against major threats, because you have the more opportunity in private land to do things. And yeah, so if people are worried about contacting me about something that may seem silly, do it. I love it. And if you want me to come and chat with people like high school students or anyone about my research and about frogs, I love that. I'm happy to do it. And yeah, there are people out there that are really working hard to make changes and to try to come up with research that can help. And I hope that like the stuff that we're developing results in more animals, more endangered species bouncing back, and better opportunities for the future generations to see them and love them like we do. So if that's a message you unite with, I'm so glad I got to be on this podcast and deliver it. And yeah, just thanks so much for having me on.
Well, thanks so much for coming on. This has been
could not
really
be more
inspiring.
excited. I am so excited. As soon as this episode, even before this episode comes out, I'm going to like tell all my Australian family about this. I'm like, okay, so you need to go and get these bricks and you got to put them in your yard. Like I can't, when the episode comes out, I'm like, you have to listen to it. If you don't, you don't love me. So this was so exciting and so fun. I couldn't be happier. Thanks so much for coming on the show.
Yeah, thanks. I appreciate it. Thanks, Fred.
You can support the show on patreon.com/wildgreenmemes. That's memes with an M. Our music was by the band RX Fire. Thanks for listening, and until next time, I'm Rhett.
I'm Io.
And I'm Anthony.
And happy Year of the Raccoon.